Hey everyone, we have Kaitlin with us here today, who's been the lead behind a number of the hardware advancements that made what we announced possible. So welcome to Schrep Tech, Kaitlin.
Thank you so much for having me, Schrep.
Before we dive in talking about the headsets today, just tell us a little bit about your background. How did you end up in this role?
Well, actually, my friends thought I was crazy. I joined Facebook about 7 years ago from Apple when we didn't make anything consumer electronics. So they were all like, what are you doing? But I guess we showed them because we acquired Oculus and I was asked to help support the mechanical team and then kind of went from there. And now I support VR hardware.
Tell me about what does it look like today versus 7 years ago in terms of our capabilities, maturity, approach to building physical products?
That's a great question. So it's a very 0 to 1 story, and then a little bit past one. One of the first things we did was create Area 404, which is actually we helped kind of define what that should be so we could start prototyping and making stuff. Then we had to ramp up teams from, when I started, the ME team was 2 people to dozens of people now who just focus on the mechanical engineering of these parts. We had to work with operations to develop our capacity, working with suppliers. It's really hard to it kind of boggles the mind where we are now. But now we're a competitor in a lot of these spaces, whereas 6-7 years ago, we weren't even a speck on the map.
There's one part of building physical things that I think for anyone out there who hasn't been part of it that is sort of oddly fascinating to me, which is the drop test. Can you talk a little bit about, one of the challenges, it's not like you just make this thing and then people put it on their shelves. They take it off their head and they go oopsie and they drop it. So one of the things we have to do is literally drop a bunch of stuff and see what breaks and then reinforce it. Can you take us through sort of how that process works for a product like this?
Yeah, for sure. You'd be surprised. It's the first thing we do once we design the product is the very first 2 that are built, I would say, are actually machines. So we get all these parts machined and we put them together for the first time. It's really exciting because usually stuff goes wrong. You make a list of all the things that's going wrong. But once you do that, the first thing you do is you actually drop it. And the reason is that drop is the hardest thing to simulate. There's all kinds of things, like materials behave funny ways. And as a really good mechanical engineering team can guess how those parts actually move when they're doing the CAD design. But in computer-aided design, everything's rigid. So we can't really guess what's going to fail. And usually it surprises us. And so that what you do is you drop it, and you take it apart and you look at what went wrong. And sometimes you can even CT scan it if you're worried that taking it apart will ruin what's happening inside. And you do a lot of analysis, like the electrical team can find broken traces and they can redesign a stronger, flexible circuit. And so it's a really fun part of the design when you first start to break it actually and figure out what's happening that we didn't guess.
Let's talk a bit about the product. And the crazy thing is it's not just cheaper, it's significantly lighter. And significantly higher performance. It's got a higher performance processor, and a much higher resolution display. Did you think it was possible when they first asked for it?
I didn't think it was possible, but I've learned not to say that. If anything, I've learned not to say that and just be like, okay, I really like the mindset of what would it take? What would it actually take? And putting your head there instead of kind of being like, we can't do it, which is usually what your initial response is.
So take us through, what are some of the big things we did to sort of make it both great and cheaper?
So, sure. So one of the first things we did is actually, I have one here. The Quest actually has 2 displays. And so when you kind of look at the Quest, there are 2 displays and the total is about 1440 by 1600 resolution. But we actually, in order to save money, it turns out that one wider display is a lot cheaper than 2 separate smaller displays. And so we decided the first thing that we have to go to a LCD screen. It's going to be higher resolution for the customer, but it's going to be cheaper because it's a single panel. And that was a big decision we made because it waterfalled into several other decisions.
And one of those big decisions as a result is the IPD adjust, right? Which is adjusting for the fact that everyone's face is shaped a little different. Your eyes are different spaced apart. And if the lenses are really far apart and my eyes are narrow, I'm not really going to be able to see well in a headset, right? And this, when we had two displays, is challenging. When we had one, is quite a bit more challenging. And I know we weren't sure we were going to get this to work. Take us through how we made IPD adjust with a single panel display.
So it took a pretty big group of people to do this. And we got the group of people together, mechanical engineers, display engineers, and we said, how are we actually going to execute on an IPD adjust without two panels? Because when there's two panels, the eye cup just seals to the panel and you can move them independently, like you said. When it's one panel, suddenly, if you're just wiping the eye cups across the panel itself, if you get any dust on the panel, these lenses act as magnifying glasses, basically. So you're just magnifying any dust that's on here. So what our team figured out is that you could move the plane that you adjust the eye cups on away from the display out of the focal plane of the system. And if you do that, if you move it back, so the bottom half towards the display is rigid, and then you bisect it a little further up, you can actually still move those eye cups, but now any little pieces of dust are not magnified, are not visible. And so that's what we've done. We actually have, we have 3 settings. And those 3 settings allow more than 90% of our customers to get a really comfortable optical fit. Whereas if we'd only had 1 setting, we could get a little bit over 60% of our customers optically comfortable.
For those who aren't in the consumer electronics market, we spend a lot of time trying to reduce price, to increase accessibility. Talk to us a bit about why is that so important? Why is that such a big deal to get $100 off the sale price of this device?
Yeah, when I was a kid, Schrep, my parents couldn't afford just any gift that I wanted for Christmas. And I really do believe that the difference between $300 and $400 for a lot of parents or a lot of people who are interested in buying this as what we would consider like an impulse buy. I don't know how others feel, but the $299 mark is a really big psychological mark, but it's also a big economic mark. It's something that's more achievable for a lot of people as an entertainment device. And so first things first, the economics side, it's a year where a lot of people are stuck at home, and also a year where a lot of people don't have as much money as they're used to having. Maybe they lost their job. I just feel really proud of the focus that we have on making this more accessible to as many people as possible. And that's what this whole product is about. Yeah, improving the product over the last one, but also getting it out to more people.
How excited are you about sort of where we are in the market, what the future products are going to look like? I know you're busy at work with multiple future products for the company. Give us a sense of what you're excited about.
Sure. I'm incredibly excited about improving the experience for people who are gaming on the device. That's one thing that I'm really passionate about. But I'm also really interested in bringing VR into other arenas. And I personally, this is my own personal opinion, I think other arenas are really ripe for disruption. Anything from real estate to work to architecture to computer-aided design are all going to be better in certain VR applications. So I'm excited to kind of branch out a little bit and develop products that are useful, that are good for people who are not only playing, but who are also working. And I think that's one big piece. The other big piece is we're developing a whole technology stack. For example, we're looking at everything from sensors and cameras to components like ergonomics to the final product. And so one of the things that's really exciting is I feel like the tide is rising on all these different components and all these different subparts. And I think that it's going to come through in a synesthetic sense in a more immersive experience in VR. Things will be easier to get in and out of. Things will seem more real when you're in VR, seem more immersive. And you'll have to think less about every step. That's our goal, is to kind of make the technology actually disappear. And we're on our way. I wish I could talk more about details, but we got to save some surprises for the future.
So just to recap, 18 months after the Quest, which is a groundbreaking product, which still has no equal in the market, we've launched a new version of this product that is significantly cheaper, is significantly lighter, has much higher resolution display, significantly more processing power, more memory, controllers that have 4 times the battery life, a full accessories program, so I can change my headset and add other things, different straps on the back. Did I miss anything? That's a lot.
During COVID.
Yes. while no one could travel, on schedule. You said we started production ramp literally the day we had planned it, 9, 10 months earlier.
I believe so.
That sounds pretty great. That sounds pretty great.
Just don't ask us to do it again this year, please.
Well, now you show it's possible. So, now we know what you guys can do. Thank you for everything you've done. Thanks for spending 30 minutes with me geeking out. I'd probably take the rest of your day, but I think you got other things you got to go do. So anyway, just want to say thanks.
Thank you. And I'll just note that there's thousands of people working on this with me. And I think we're all pulling in the same direction on this stuff. And I just wanted to thank them too. It's a major effort. It's really nice to be here with you, Schrep.